Hey guys, I'm going to go over these notes dealing with parametric applications. You can see that you've got your typical x equation and your y equation. The x dealing with the horizontal motion and then y dealing with the vertical motion. So the x equation is pretty simple. It's x equals v naught t cosine theta, where the v naught is your initial velocity. The t, your parameter, just deals with time, usually in seconds. And the cosine theta, so that's the angle of elevation, the angle of projection. Okay, and then look over here, a little bit more to the y equation. You have v naught, the initial velocity, you have t, time, sine theta, and then minus 1/2 g, that's dealing with, we'll get into gravity a little bit, but that's that's going to deal with the acceleration rate of gravity. So minus 1/2 g t squared plus h, so h is your initial height. Okay. So for gravity here, if the problem's dealing with feet, then because acceleration rate is 32 feet per second squared. So for this formula here, we'll just substitute our 1/2 g with 16. So half of that 32. And then if it's in meters, it's usually 9.8, or the acceleration rate is 9.8 meters per second squared. So 1/2 of that, so our 1/2 g of 9.8 is 4.9. So we'll substitute that in if it's dealing with meters. Okay, so different problems will use different forms of measurement, units of measurement. So look at this example here. Denise Parker was a member of the U.S. Olympic archery team in 1988 and in 1992. Denise shoots an arrow with an initial velocity of 65 meters per second. Okay, so that's given us our v naught, which is 65. But it's also telling us that this problem's working in meters, so that's going to help us when we start dealing with the gravity. It's at, she's shooting it at an angle of 4.5 degrees with the horizontal. So that's your angle of elevation, 4.5 degrees. At a target 70 meters away, so we'll use that to answer the question. Denise holds the bow 1.5 meters above the ground, so that's the initial height. So we'll need that. And then, like I said, the last thing that you're going to need is that 1/2 g. So our 1/2 g, because we're dealing with meters, we're going to use 4.9 when we sub that in. Okay. So it says write a set of parametric equations for the path of the arrow. So let's work with our horizontal first. So x equals, we'll just follow our formula. So the formula is v naught t cosine theta. So our equation will be 65 t cosine 4.5 degrees. I don't like the way I wrote that. There you go. And then y is equal to v naught t sine theta minus 1/2 g. So we'll substitute that in. T squared plus h. So for our example, we'll say y is equal to 65 t sine 4.5 minus, we're going to substitute the 4.9 in for our 1/2 g because we're dealing with meters, t squared. And then my initial height is 1.5, so we need to tack that in on the end there. Many times it's written in the front as well. I will say this, you're going to see some problems on your homework where, you know, the ball's leaving the ground or something. So, you know, you definitely wouldn't have an H there if it's leaving the ground and then it's hitting the ground. All right, so there's your parametric equations. Now, how far above the ground will the arrow be when it hits the target? Okay, so remember that the target was 70 meters away. Okay, find the answer to the nearest hundredths of a second. So take your calculator. Oh, let me slide that up. There you go. Take your calculator and see if you can see this. There it is. Good. I'm going to go to y equals. I already plugged it in, but there's x equals 65t cosine 4.5. I plugged in the y equation. Let's see. If we go to our window, I just used the default. We're definitely not going to need the full 6 seconds there. And then if you look at the X max, I just set my X max at 75. The target's 70 meters away. She's not going to shoot the arrow more than 25 meters, you know, above the ground. So I just did 25. You could probably do a little less than that. And then let's take a look at the graph. Okay. So here's the graph. So you're going to use trace a lot for this. Can be very helpful. So what we're going to do is we're going to trace and just kind of follow it from left to right. You can see right here, you may not be able to see, but when you're looking at your calculator, like right now mine says t equals 0.5. And then it's almost 34 meters away. So we're going to go all the way to 70 or close to 70. So right there where my cursor is, I'm 1.05 seconds in the air, and I'm at almost 68 meters away. And then the next one was 76 meters away. So our target is somewhere between those two. So what I'm going to do is I'm going to use table set. So if you hit second window, wait, I'm going to go back because I don't remember my seconds. There it was. I'm at 1.05 seconds. So I'm going to go second window and let my table start be 1.05. And then my change in the table, I'm going to do 0.01. Okay. It did say in that problem, find the answer to the nearest hundredth of a second. So if I choose 0.01, now when I go to my table, I'll be able to see how many seconds it'll take for the arrow to hit the target. So here I'm at 69.99 at 1.08 seconds. And then it's 1.29 meters off the ground. So here's your horizontal, the X. And then here's your vertical, the Y. Okay, so let's kind of write down those steps. We use trace. To follow the graph from left to right. And then once I saw that it was close to 1.05 or a little past 1.05, I went to table start, and I had it start at 1.05, and then I made my change in table 0.01, because that's what the problem says right here, hundredths of a second. Okay, and then when I checked 70 meters away, we'll say the arrow is 1.29. That's what the Y value was there. 1.29 meters above the ground. That's what the problem's asking. And I'm going to go ahead and throw in at, what was it? Let me check again. T equals 1.08. Okay. Now, part C says, if the small, it's telling you it's a small, if the small bullseye was 1 meter above the ground and was centered on a target with a 0.5 meter radius, okay, so the full target is 0.5 meters, did she hit the target? So you've got a target here. So if the bullseye is 1 meter and the radius here is 0.5, so the top of the bullseye would be 1.5 meters and the bottom would be 0.5 meters. So did she hit the target? She was 1.29 above the ground. So that would hit somewhere right in here. So did she hit the target? Yes. She made it onto the target. Did she hit the bullseye? No. We don't know the size, but we do know it's small, so it's not going to take up half of the target. More than half. So we would say no. She hit above. So yes, she hit the target. No, she hit above the bullseye. So, I only gave you a couple of these to work on your worksheet, your homework there. But I just wanted to show you this. Like I said, they can be a lot more complicated than what we're doing. Just going to keep it simple for you. But I hope this helps, and let me know if you have any questions. Have a good day. Bye-bye.